Hello everyone. Previously we had discussed on the DRY principle, right? So it was very simple. Today let's discuss on the topic Y.A.G.N.I, right? So Y.A.G.N.I is nothing but you aren't gonna need it, right? So you aren't gonna need it. Let's get into the definition part here. This is nothing but the abbreviation here. You aren't gonna need it, Y.A.G.N.I. So Y.A.G.N.I means here, don't build features you don't need right now. Currently, if you don't need them, don't build that feature currently, right? So if you don't need something, don't build it currently in simple terms, right? So we have to implement only what is required for the current requirements, not hypothetical future ones. So that's what the Y.A.G.N.I says, right? So what it says, Y.A.G.N.I means don't build features you don't need right now. So abbreviation itself says here, this one part here, you aren't gonna need it currently, right? So Y.A.G.N.I means don't build features you don't need right now, right? So we have to implement only what is required for current requirements, not the hypothetical future ones. Just keep this in mind, right? So this is fine. Now adding features, these uh, two are important points, man. First two lines, this is one point and this is one point. I find this one very important, so I just wanted to tell you this one. So adding features just in case makes code harder to maintain and increase the bugs, quite obviously, right? In case for the future, right? So these things if we keep in mind and then if we add it, then it might make the code harder to maintain and increase the bugs, which is not required currently, right? So which is not required currently. If we keep on adding that one, just in case, uh, right, of this one, this can make the code harder to maintain and increase bugs. We may never use them, right? So just for the sake of future use, we would have implemented that one and we might not use them at all, and by the time we need them, the requirements might have changed, right? So and by the time we need them, the requirements might have changed, right? So this is one of the things. And one more important point here is Y.A.G.N.I helps keep code focused, right? Small and easy to change when real needs arise. When real needs arise, right? Simple, right? So now let's try to understand this one with a very simple example, right? First, let me write the code which is basically the bad way, and then let's see what is the good way of implementation or implementing it. Same thing, right? So now let me go with here def the function name compute total uh, with points. Simple. Let me go with quantity here. This one will be unit price. This is also fine. Let me go with loyalty points here. This one, let me give false, boolean value false. This is fine. Now let's do one thing. I'll just consider sub here, nothing but the subtotal. So this one will be quantity into unit price, right? So this one will be quantity into unit price. This is fine. Next, let me go with tax, that is equal to sub into 0.18, subtotal into 0.18. So this is fine. Next, let me go with the total, just total. Let me assign this one to the sub plus tax, right? So now let me make use of simple if condition here. This is not needed now, so we will be just adding this one for the complexity. So this is not needed now, this if condition is not at all needed. Simply we will be adding this one just for the this just adds the complexity just for the future use. So we'll be adding this one, right? So basically this is the bad way of writing the code. So that's what Y.A.G.N.I screams actually. So we shouldn't build the features that we don't need currently, right? So that's what Y.A.G.N.I says. So this isn't needed currently, so this just adds the complexity. So this is the bad way of writing the code. Let me proceed. So I'll just go with uh, loyalty points here. This is fine. If loyalty points, then I'll just go with points equals int of total, right? 10, right? So this is fine. Now let's print something for the interactive purpose here. So I'll just go with, let me go with the string interpolation here. I'll just go with loyalty points. This is fine. Finally, let me go with points. So this is fine, I guess. So yeah, let me return the total here. Let me return the total here, right? So we are done with this. We are done with this, right? So basically, I just want to say this one. Let me give this is not needed now. Uh, Now this just adds complexity, right? So we are just using it just to just for the example sake. I just wanted to show you the bad way of writing the code and good way of writing the code. Means good way is nothing but which follows Y.A.G.N.I, right? So now let's go with the good way. Let's only implement what is needed currently, right? So I'll just go with def compute total. So this is fine. Let me go with the quantity. So and also unit price. So this is fine. Within the compute total function, let me go with the subtotal. Let me assign this one to the, I should have copy pasted one. So this is fine. Quantity into unit price. Also tax equals sub into the same thing. This is fine. Let me paste this one. And finally, let me go with, let's return sub plus tax, right? Sub plus tax basically, right? So we are implementing only what is needed now, right? So this is good way of writing the code, right? So accordingly with the Y.A.G.N.I principle. So sub is nothing but the subtotal, whatever I have used here. Don't get confused. Tax is nothing but the 18% GST. I'm going with 0.18 here. So we are just returning the final amount, right? So let's try to use it, or let's go with the test case or the example usage here. So I'll just go with T1 equals, let me go with compute total, compute total itself, right? So let me pass here two numbers, nothing but 3 comma 100, some random numbers I'll pass. So here I'll just go with T2 equals again compute total. Let me pass this time some 1500, right? This is also fine. Let me go with a print here. Print, let me go with a string interpolation. So this one will be order 1. So total, so this one will be T1, right? So this is fine, man. Finally, I'll just go with print. So this one will be string interpolation again. Let's make use of the string interpolation. This is fine. Order 2. Mm, let me go with a total. So this is fine. Let me go with T2 here. I have considered T2 itself, right? T1 and T2. Yep, this is fine, man. Now, the output that we need to get here is order 1 total is 354, right? So order 1 total is this one. We are going with a formula basically. So this one has to be 354, and order 2 total is nothing but we have to get 1770. Right, so this one will be what do we call? We will be going with the 3 into 100, right? Quantity into unit price. So this one will be 300 and the tax is 54. So this one is subtotal into 0.18, right? So this one will be 54 plus 54 will lead to this one 354. The same goes with second one as well, man. Simple, right? So this one will be 15 into 100, nothing but 1500 plus 270 is nothing but the tax. So this will be 1770. The output that we need to get here is 1770. So let's see. I'll just go with the Python. So here, let me copy this one, paste it over here, .py. So see here, we are getting the output 354 and 1770. Simple. So we are not making use of any extra unused features here. This is clean and completely simple. This one, compute total, which I'm speaking. This is good way. Let me write here this one as good way, and this one let me consider this one bad way just for the understanding purpose. That's it, right? So we are done with the output part. Right, so I'm in coding part as well as output explanation part. So let me summarize whatever we have learned so far. So first thing, what Y.A.G.N.I focuses here is we have to build only what is required right now. Right, so I'm just summarizing whatever we have learned so far. Right, so we're done with the Y.A.G.N.I principle. Right, so Y.A.G.N.I just focuses on what we need currently. Right, so then one more thing, it avoids wasted effort and reduces the complexity. And the final one here, accordingly with the code, if the loyalty points are needed in the future, then we can add them when the requirement arrives. So this one, it was not required, right? So I have written here, this is not required right now. This just adds the complexity, right? So if loyalty points are needed in the future, we can just add them when the requirement arises, right? So this is about the Y.A.G.N.I principle, right? So we have discussed about the DRY and Y.A.G.N.I. Next we'll be discussing about the solid principles, right? So we have already done this one using the JavaScript. So again, we'll be going with the same SOLID, solid principles, right? So we'll be discussing on the solid principles, and then we can hop into solving some good LLD problems, right? Solving some good LLD problems. So before that, we have to know at any cost, before solving the LLD problems, at any cost, we have to know oops. We have already discussed oops in Python. We have done the same thing in Java, and we had done the same thing in Java and JavaScript as well. So we will be doing same thing with the Python now. Same thing with the Python. We'll not leave anything in the JavaScript, Java, as well as the Python. These three things, right? So we'll not leave any concept. So we are gonna repeat the same thing. We will do everything. Whatever, if I feel that if I miss something, I'll take that topic and we'll be discussing here. No worries, right? So now we have discussed DRY and Y.A.G.N.I. Next, we'll be discussing the solid principles, and we are done with the OOPS concepts as well. We have already discussed that one, right? So after that, we can solve the this one, some good LLD problems about 20 to 30 or 30 to 40, right? So every day we'll be going with one video, as I've said. So now, as I've said, we are done with DRY and Y.A.G.N.I. Next, we'll be going with the solid principles, right? For now, this is it. Thanks for watching, guys.